Hi, welcome back to EMC 640, Quality Improvement in EMS. Upon completion of this lecture, the student should be able to discuss what is Six Sigma, what does the acronym DMAIC stand for, and they should understand the basic Six Sigma course objectives. What I want to present to you in this lecture is actually an introduction to the Six Sigma courses that exist. Specifically, this is the introduction to a Six Sigma Yellow Belt course, which is usually a 2-day, 16-hour program that introduces students to Six Sigma. The idea of the Six Sigma course is to introduce participants to the benefits, concepts, terminology of Six Sigma, to provide participants with the skills needed to be a contributing team member, to provide an introduction to the DMAIC method, and to serve as a first step for those individuals who are interested in more advanced levels of Six Sigma training. We also usually utilize a set of enabling objectives. This set of objectives, as a result of attending the workshop, we'd like for participants to develop an appreciation for the need to focus on customers. We'd like for them to understand the importance and meaning of data and fact-driven management, to understand the concept of process and management improvement based on process, to appreciate the concept of proactive management, to appreciate the importance of boundaryless collaboration, and finally to understand that while it's important to strive for perfection, on occasion you will have to tolerate failure in the short term. This last objective is usually the most difficult for most students, as traditional approaches to management is focused on making rapid, knee-jerk reaction changes when data appears to not be what they would like to see. There's several reasons that historical attempts at quality haven't been successful. In particular, organizations quite often were structured with all strategic and operational decisions coming from the top. This failed to capitalize on the benefits of utilizing individuals throughout the organization to solve problems. Also, organizations have used outdated operating systems and technology. While technology and operating systems can be a benefit, it's important that they be utilized in the correct contexts. Quite often, if problems aren't solved before new technology is implemented, the problems can get even worse. Also, historically, organization dealings with employees has been less than honest and open, sometimes harsh and typically disrespectful. Historically, most change initiatives come to fruition. Finally, changes were not data-driven. Well, the Six Sigma approach to quality tries to address many of these challenges. But it's important when you're thinking about change to think about the steps of change. In particular, Caffey and Scott actually proposed something called the transition curve. And I found this very beneficial with working with organizations in trying to implement change. When you originally start talking about some new program or start talking about making an improvement to some process within an organization, quite often there's complete denial that anything's going to change. You'll see individuals not show up for meetings, not take this change serious. Quite often there's not many comments. However, as efforts start moving forward and individuals start progressing towards implementing a change, quite often you'll see blatant resistance. This is usually the point where you have very vocal individuals in the organization speaking out, complaining about the potential change, complaining about how it's going to be a disbenefit to them. And at this point, the resistance is so strong that many organizations abandon change. At this point, quite often when you run into resistance, if you can just stay with the resistance, let the individuals talk, let the individuals express themselves, and let them utilize the excess energy they have, then quite often you can actually drain that energy from the individuals. And at some point, you'll actually get to the point that they'll be willing to explore new possibilities. That's when you can move to the right into the exploration stage. This is where you want to work with individuals to try to develop a win-win situation for both the organization and the individuals. This is the most productive time. However, during this exploration time, you have to be very careful because individuals can revert back to the resistance stage if you don't manage expectations and keep momentum moving forward. Ultimately, what you would like to accomplish is get to the commitment stage where you have individuals that are willing to buy into this new perspective way of processes working within an organization. Well, earlier we talked about the history of improvement. We talked about Walter Shewhart, Edward Deming, Joseph Juran, and Blanton Godfrey. So I just wanted to reiterate that this approach this lineage has led to the development of Six Sigma. So when we think about Six Sigma isn't a new methodology per se, but instead is a refined methodology that's come from the historical work that's been done before it. And there's a long lineage of quality efforts that have been aggregated to really form Six Sigma. And as you can see at the top of the stair steps, there's actually a question mark, meaning that there'll probably be a new name and a new concept that's developed. One of the concepts that's gaining some traction now is something known as Visual Six Sigma, which is the integration of Six Sigma with a lean approach to how to look at data, to utilize it in the most efficient way and the quickest way to make improvements. As we've talked about before in EMS, we really went through these 5 stages. We started out completely with a quality assurance approach to quality, and we borrowed that from hospital organizations. We slowly moved towards quality improvement, where we started focusing on improving some clinical processes. However, where we really want to be is in the quality management realm. But even with the quality management realm and calling it quality, there was a focus on clinical as opposed to focusing on all processes in an organization. So slowly we started moving towards calling it performance improvement, and about the same time, as we'll see in our next lecture, the Michael Baldridge Performance Excellence Award transition from calling it the Quality Award to the Performance Excellence Award. But ultimately what we're after is a management approach to the way we do things that focuses on all pieces of an organization. We also briefly mentioned in the last lecture how Lean and Six Sigma has been utilized in healthcare. And in particular, we mentioned the 100,000 Lives campaign and the 5 million Lives campaign that are processes that are being implemented by the Institute for Healthcare Improvement, Don Berwick's group out of Boston. A couple other publications that are noteworthy are the 2 you see on the left-hand side of the slide, Crossing the Quality Chasm and To Err is Human. Well, if you think about Six Sigma and where Six Sigma actually originated, it originated at Motorola. Motorola, like many companies, started out with trying to reduce cost and deal with quality problems in manufacturing. Bob Galvin, CEO at the time of Motorola, decided that quality needed to be the first topic on every executive list. And this really wasn't an overnight idea that was developed by Bob, but it was actually one of his researchers that came to him and said, I have this set of skills that I feel if we teach everyone in the organization, we can actually communicate in a common way about the quality of everything we do in the organization. So slowly, Six Sigma became a company-wide initiative throughout the organization. And with Bob making quality the first topic on every executive meeting agenda, it rapidly gained traction. It actually led to Motorola being the first recipient of the Malcolm Baldrige Performance Excellence Award. Well, since Bob Galvin has actually retired from Motorola, but he's still very involved with quality and he still sees huge benefits in the quality movement. Of recent, he's actually got involved with the National Energy Project. He had an idea one day as he was at his residence and the power went out that he lives in the United States of America. And he couldn't understand why, with the quality technologies we have today, we still have the number of power outages that we do. So he actually gathered a large group of the major energy power suppliers in the United States together to look at how we could decrease the number of power outages that take place in the United States. He actually involved Blanton Godfrey in this process and asked for his help in facilitating the group. When numerous companies and industries have utilized Six Sigma and continue to do so today, and we're rapidly seeing Six Sigma become more prevalent in the EMS community, with many organizations utilizing it either as a overarching concept or utilizing some of the principles that we'll talk about. So what is Six Sigma? Six Sigma focuses on the reduction of variation and the improvement of processes. It's a structured approach to making breakthrough improvements to key organizational processes that are most important to customers. This is accomplished by one of two things, either by reducing variation or centering a process on a given target. It's a way to manage and improve processes. It uses the scientific method of problem solving. It's a way to reduce errors and defects to near zero levels. It's an innovative approach to training, a way to achieve significant savings, and it's also a statistical measure of variability. Now, it's important when we think about Six Sigma and we think about any improvement methodology, and specifically Six Sigma emphasizes process but focuses on results. Some historical approaches to quality haven't necessarily done that. We mentioned in the previous lecture Walter Shewhart in the 1920s and his advent of statistical process control. With statistical process control, the idea was as long as we can control the process and reduce variation, we'll produce the outputs that we desire. Unfortunately, that's not always the case. Processes may not be centered. They may not be we may even, if you remember also from the first lecture, we may be doing the wrong thing right. So if we keep doing the wrong thing right, we're not going to produce the outputs that we want. So when we think about improvements, we have to think about both the process and the results we hope to accomplish. We have to think about what really matters to the bottom line of the organization. What are the bottom line results? These could be clinical results, customer satisfaction results, or financial results. We also want to be able to measure the impact of each project. And we want to engage in projects that actually provide some return for their investment. Also, we can think about projects in terms of how much each project contributes this year and will continue to contribute in future years. So we want to think about the aggregate benefit. Again, we want to focus on results. Improved customer patient satisfaction, clinical outcomes, response times, shoot times, turnaround times, cost per patient, cost per response, cost per transport, continued growth or sustainability of the organization. But Six Sigma is also a philosophy. It's a belief that perfection is possible. Well, in recent years, Lean has become more important and been integrated into the Six Sigma toolset. Many organizations have debated over whether to implement a Lean process, whether to implement Lean training or Six Sigma training in the organization. I like to think of both as sets of tools that we can put in a toolbox and utilize for improvement projects. Lean is usually associated with the Toyota production process. If we think about lean, becoming lean is a process of eliminating waste with the goal of creating value. It's a systematic approach to identifying and eliminating waste, non-value-added activities through continuous improvement by flowing the service at the pull of the customer in the pursuit of perfection. There's really 5 key principles to lean. The first is value. We have to look at what customers are willing to pay for. Next, we want to look at the value stream. These are the steps that deliver that value to the customer. Next, we look at flow. How can we organize this value stream to be continuous? Next is pull, responding to downstream customer demand. So how can we flow at the pull of a given customer? And then finally is perfection, relentless continuous improvement, or culture. These have really been adopted in something known as the Toyota Way philosophy. And if you're interested, you can actually find a lot of information from James Womack at MIT. When we think about value-added and non-value-added, a value-added activity is any activity that impacts output or outcome of a customer, while non-value activity or non-value-added activity is any activity that doesn't affect the output or outcome of a customer. If you think about most processes are composed of 95% non-value-added activity. So there's a lot of waste that could be eliminated. There's 8 specific wastes that we look for from a lean perspective: overproduction, excess inventory, defects, non-value-added processing, waiting, underutilized people, excessive motion, and transportation. Now, it's interesting from the lean perspective. People think about lean, and the terminology means to actually decrease in size, decrease the number of employees, increase the workload on individuals, when in essence that's not the case. Another concept of lean is something known as takt time, where you actually look at how much time it takes to accomplish a task. And one of the ideas in lean is to try to create work processes where individuals can work at a slow pace but produce at very high levels. So the idea is actually not to overwork individuals and to maintain that reserve capacity in case there is a surge. Well, if we think about adding Lean and Six Sigma together, we can think of Lean Sigma or Lean Six Sigma as using a data-driven structured approach to reduce variation, improve processes, decrease cycle times, and reduce waste, thereby improving overall customer value. The advantages of the Lean Sigma approach: they directly involve senior management. They're inclusive of all processes and activities of the organization. They focus on the most important issues facing the organization: patient satisfaction, clinical outcomes, financial efficiency. They demand a measurable return on investment. The methodology utilizes a high level of accountability for achieving results that actually matter. They're project-oriented, meaning projects have beginnings and an end. They provide a structured roadmap for each step of the project, and they can be used by anyone in the organization. So what about Plan, Do, Check, Act and Plan, Do, Study, Act and other methodologies? Well, again, Six Sigma is an evolutionary process. It's evolution and integration. It's the development that was given birth from these previous methodologies. The benefit of Six Sigma is it's a more defined roadmap, and I'm sure better roadmaps will exist in the future. If we think about the components of Lean Sigma, there are really 3 key components: the cultural, organizational, infrastructure aspect, the common methodology or roadmap aspect of the methodology, and the tools. So let's first take a look at the culture and organizational infrastructure aspect of Six Sigma. From an organizational infrastructure perspective, it's very important to think about how you'll manage the implementation of any improvement methodology, but that's especially the case with Six Sigma. You don't want to utilize Six Sigma for every improvement process in your organization, as again, you want to choose projects that's going to provide a large return on investment. So it's the things that are most important, the things that are most challenging in the organization. One of the ways to make sure that you utilize this methodology or any methodology in the correct format is to think about your infrastructure. As you see here, we have a management council. The management council is part of the executive team. Work processes exist below the management council. As issues arise, potential Six Sigma projects are either brought to the management council, or the management council actually suggests Six Sigma projects to particular managers. Well, in this process, there's two pieces that are important. One is to actually ensure that there's a process owner for each process that's going to be improved. And the process owner quite often shouldn't be the person that's going to lead the particular Six Sigma team or improvement effort. The reason for this is at the end of the improvement process, you would like someone to be responsible continuously for this particular process in the future and to monitor it over time. We'll talk about later in the course ways you can do that in a very efficient, non-time demanding manner, but it's important that someone be responsible for a process in the future once it's identified and you start to manage it. Also, it's a benefit to have someone that's somewhat impartial to that particular process to facilitate a given team. So you may choose someone from your fleet operations to actually facilitate improvement related to a clinical process, or someone from the clinical team to actually facilitate a team for a fleet improvement process. It works well because, in essence, the facilitator is facilitating the flow of the Six Sigma process improvement effort and not the particular process at hand. And you would actually like them to say as impartial as possible to them what's actually taking place within the team. Well, people come to Six Sigma projects in different ways. One way is to actually utilize a strategic management approach. You think about the vision of the organization. What are your critical success factors? What are your strategic goals? What are the key business objectives? And from that, many people actually develop some semblance of a balanced scorecard that was popularized by Kaplan that we discussed in the system design class. So in this sense, you end up with a set of key business processes. And these key business processes often are measured through a set of key performance indicators. Well, you may see that one of the performance indicators is not achieving the level of effectiveness or efficiency that you would desire. That could be one opportunity. Another opportunity may come from actually taking the vision and working backwards. And as part of the strategic planning process, you plan particular projects. So here you can see this key strategy, the strategic quality goals, the sub-goals, the annual goals, and you see those actually drill all the way down to individual projects or initiatives. Ideally, all of this in some way will flow up to some organizational scorecard from the departments so that you can actually measure what's taking place throughout the entire organization. Now, when we think about Six Sigma, there's several different roles, and I'd just like to kind of give you a brief introduction to the different levels of Six Sigma. As we mentioned, there's something known as a Six Sigma Yellow Belt. The Yellow Belt actually works as a team member. They understand the needs to collect data, conduct trials, analyze data. They suggest ideas to make projects successful. They provide content expertise, which is critical. Again, one of the reasons for historical failure is not involving everyone throughout the organization. Quite often, it's the individual that actually performs a process that may hold the key to improving that process. The next level is the green belt. The green belt works as a team member. They communicate project's objectives, Six Sigma philosophy to associates affected by the project. They carry out technical tasks, collect data, conduct trials, analyze data. They suggest ideas to make the project a success. Again, quite often they provide some level of expertise to the team and they facilitate project teams. The black belt is the next higher level. They cultivate a local network of Six Sigma individuals. They provide one-on-one support to project facilitators. They pass on new strategies and tools in the form of training, workshops, case studies, local symposias. They find applications and opportunities for Six Sigma strategies and tools both internally and externally um, with your suppliers. They surface opportunities through partnerships with other organizations. They recommend team membership, they facilitate and lead complex project teams, and quite often they serve as mentors to the green belts in the organization. And then there's a master black belt. Their duties include all of those of the black belt, plus they provide facilitative and technical expertise to the black belts. They provide continuing education, and they facilitate project prioritization with champions and executives. And then the last role is actually champion. This is one of the most critical. The champion quite often is the individual that may not hold um, the expertise in how to perform all the tools in the Six Sigma tool set, but they understand the high level reasoning behind Six Sigma. And they're there at the executive level to support Six Sigma teams, to get the teams what they need. They decide what projects need to be utilized, and they serve as a go-between between the executive committee or management council in an organization and the individual Six Sigma teams. These individuals are key to Six Sigma project success. Well, now let's take a look at the common methodology or roadmap. The Six Sigma methodology utilizes something known as DMAIC. DMAIC standing for define, measure, analyze, improve, and control. If we think about define, in the define stage, we want to identify, prioritize, and select the right projects. With measure, we want to identify key processes, characteristics, and process parameters, understand processes, understand the measurement system capabilities, and measure current process performance. With analyze, we're going to talk about identifying the key causative process variables or factors and determining which factors. Once we've analyzed the factors and we determine which are the key factors, next we want to move to improve. In improve, we're going to determine what will be changed and establish predictive models and optimization of performance. And then finally, we move to control, which is about sustainability or actually holding the gains in performance that we've achieved. So here you can see the cycle. We define by understanding what the customer wants. We validate the projects. We move to measurement, where we actually look at the measurement system and look at the process and look at establishing a baseline. We move into analyze, and this is actually the stage where we start to figure out how to fix a particular problem or improve a particular issue in an organization. From there, we move to improve, where we actually implement that, and then we move on to control. So let's take a look at some of the tools. There's really two sets of tools. One set of tools we call hand tools. These are things such as brainstorming, cause and effect diagrams, graphs, charts, histograms, mistake proofing, Pareto analysis, process control plans, process flow diagrams, scatter diagrams, run charts, control charts, stratification. Many of these you could simply do with a pen and paper. Some of the tools, however, require a little more sophistication. Things like value stream analysis, analysis of the variance, correlation and regression analysis, design of experiments, variable mode effect analysis, hypothesis testing, statistical process control, measurement system analysis, process capability studies, and quality functional deployment. We call these power tools, and they require a little more computer support than the hand tools do. Well, I always warn individuals that a Six Sigma class is not a statistics class. The idea is just to figure out how to utilize data in a way that we can answer questions. But it's important to understand the statistical nature of Six Sigma and the statistical meaning of Six Sigma. So let's take a look at an example. Think about a commute to work. Let's say that it takes you 20 minutes to drive to work. If you think about driving to work on successive days, every day will be a little bit different. Now, it may only range from 18 minutes to 22 minutes, but there's a distribution there. And if we were to refine the measurement system to seconds and milliseconds, we would see there's even more variability. So there's always variability that exists in a process. Another way to think about it is thinking about kicking a field goal. Here you can see the distribution of where the footballs land over successive kicks. If you were to look at this distribution of footballs, you'd actually say that the kicker needs to center their process. They need to move towards the right. However, in this example, we see that the tails of the distribution are outside of the goalpost. So here, they need to work on reducing variation. Well, in essence, this is the only two ways that we can improve a process. We can center the process and reduce variation. With the Six Sigma process, a good way to think about it is that we have a process that has very little variation, that is very centered on our target, between our specification or between our goalpost, as you see here, with a very narrow distribution of footballs that is very centered. So if we think about processes, if we look at things from a statistical perspective, there's only two ways to improve anything. We can either reduce variation or we can move a process towards center. When we talk about Six Sigma meaning 6 standard deviations, what we're saying is there's actually 6 standard deviations. What we're saying is if you go out 6 standard deviations from the center of a process, there's that only 3.4 times out of a million would the process produce an output that falls outside of an upper or lower specification limit. Now there's a little more to the measure. You see the 1.5 sigma shift at the top, just above the blue distribution. And that was actually added by the folks at Motorola, who said all processes, depending on whether you measure them in the short term or long term, are going to have some degree of variation. So what they decided is that all processes should be measured in the short term and then expected to have 1.5 sigma variation on top of that over the long term, because there's always some variation there. So that's not a critical point, but it is part of the methodology of Six Sigma and how we get to 3.4 parts per million opportunities. So in essence, what they're saying is that when we talk about perfection, and you saw in the quote earlier, perfection is possible, the thought is that perfection is possible, but perfection is getting to these sigma levels. And even at these sigma levels, we see there's still an opportunity, 3.4 times out of a million, that we still could have something that's done incorrectly. So one of the key things to take from this slide is that when we're talking about any measure, we're talking about a measure of goodness using a universal measurement scale, and that all processes are going to have variation. So two numbers that really never exist in my mind are 100% or 0. If someone says that they have 100% endotracheal intubation success rate, then the probability of it not being 100% is higher in the coming months, simply because it's at 100%, because all processes have variation that are inherent to them. Sometimes they just don't show up. Sometimes they don't show up for a long period of time. But again, all processes fall on a distribution. So if we think about this in comparison to sigmas and missed field goals, here you can see that if we were at a 2 sigma level, we'd miss 3 out of 10 field goals. If we were at a 3 sigma, we'd miss 67 out of 1,000. But when we jump to 4 sigma, we're down to 6 out of 1,000. 5 sigma, 2 out of 10,000. And then, of course, at 6 sigma, 3.4 out of a million. So here are some processes you run into in daily life, and they're 6 sigma level. You can see, thank goodness, that the airline industry is relatively safe at better than 6 sigma. However, some of the processes, like U.S. tax advice, prescription writing, restaurant bills, and payroll processing, are fairly low, with U.S. tax advice being close to 2, which is 6 out of 10 times, or 3 out of 10 times, which is 3 out of every 10 times being incorrect. Well, here at the bottom of the scale, on the x-axis, you can see the sigma level, and you can see the defective parts per million opportunities on the y-axis. As you can see, as you move from 3 sigma to 4 sigma, there's an exponential improvement in the level of quality. So quite often individuals will tell me that it's impossible for a particular process to be a 6 sigma level process. They may be correct. However, the idea is that if we utilize this tool set, we can actually move processes further along the sigma levels. And even if you just move from a 3 to a 4 level sigma, we make drastic improvements. Also, this is one of the key concepts of Six Sigma. Because Six Sigma utilizes more advanced statistical methodologies, we're capable of moving from 3 Sigma to 4 Sigma. If we think about historically the use of statistical process control charts that have been around since the 1920s, they only allow us to measure to the 3 Sigma level. So if you want to move beyond 3 Sigma level quality, which you see is an exponential improvement in the level of quality you provide, you really need to utilize some of the more advanced methods. Well, let's look at this from a let's look at Six Sigma from a problem-solving perspective. Historically, people have practical problems. They'll hold meetings, and in the meetings, they may brainstorm a little bit about practical solutions. They'll test these solutions, quite often one at a time. But there's really no data that drives the decision-making process. As Albert Einstein said, no problem can be solved from the same consciousness that created it. So we have to think in a different way. Think about a typical response. A typical ambulance response produces data over time. Slowly over time, we'll always see a distribution form. We need to understand what it is we're actually trying to change. So quite often we look at these frequency distributions to see what the parameters of our process are. Quite often we look at these distributions to see the capability of our processes. In this process, say we want to meet a 90% compliance rate at 8 minutes 59 seconds for emergency responses. We could also think about intratracheal intubation success the same way. Over time, we're going to see a distribution. And maybe we've set a lower limit of 95% intubation success rate. But what we see here is that the distribution's from 80% to 100%. Well, in this example, if we have a 75%, that's outside of what our process should be producing. So it makes sense to look at that individual month that we have a 75% intubation success rate. Otherwise, if we want to improve intubation success, we need to focus on the whole process and look at the way that we actually perform intratracheal intubations and work to improve the whole system. Remember again from lecture 1, we mentioned Deming's belief that 95% of problems are system problems and only 5% are people problems. That's not saying that you never have individual performance problems, but the majority of times when you look closely at problems, you'll see that they're process-oriented. If you can improve the process, you can actually prevent individuals from performing the action incorrectly. The same with response times. In this example, you can see the 12 minutes 52 seconds is outside of the distribution. It makes sense to investigate that particular late response. However, in this system, the system is designed to have responses that take up to 10 minutes, even though they hope to accomplish 8 minutes 59 seconds 90% of the time. So it doesn't do a whole lot of good for the organization to investigate just the responses between 8 minutes 59 seconds and 10 minutes, as there could be special cause variation points, which we'll discuss what that means later. There could be assignable causes actually in the other part of the distribution below the 8 minutes 59 seconds. So it's important that we look at all sources of variation, as key sources may be hidden throughout the distribution. The difference in how we would approach this is that in the 12 minutes 52 seconds, we would take action specifically on that response. We would investigate why it was late. However, the remainder of the data, we would utilize the tools to actually look at the whole distribution, look at the causes of the entire distribution, and determine which of the causes are the greatest sources of variation. And then we could take action on those particular factors to try to reduce the level of variation in the process. Again, the action we take is really based on the concept of whether something is special cause variation or assignable cause, or common cause variation, which is inherent to the process. So when we think about special cause, it's some unusual event that's taking place. The process was done differently for some reason. There was some specific cause for the late response. There was some specific cause for the monthly intubation rate to be below what you would like to see. On the other hand, common cause variation is the distribution. It's the causes of the distribution. It's the reason that we have a distribution of data. It's the noise issues that cause variation on a day-to-day basis. It's the issues that cause slight variation on a day-to-day basis. So again, if we think about action, with the special cause variation points, we're going to investigate the data point. We'll take action to prevent it in the future. However, if it's common cause variation, we're going to investigate the inherent causes of variation and make changes to the whole process. So in essence, that is Six Sigma. We utilize the Six Sigma toolset to look at common cause variation, to identify special cause variation. So in essence, that is Six Sigma. We can utilize it to identify special cause variation and deal with those special cause variation points. But the tools are most helpful at looking at all sources, and especially common cause sources of variation, to actually get inside the process, understand the process, and then actually improve the process to the level that you want to improve, to the level of performance that you hope to accomplish. Well, the way we do that is we actually have to go through a transition process. Instead of simply taking the practical problem into a meeting and discussing practical solutions, with the Six Sigma approach, what we'll do is we'll actually take the practical problem, define it in statistical terms as X's and Y's. By defining it in statistical terms, we actually have an output. Now we can measure how various sources of variation affect a given output. We solve the statistical problem by collecting data, utilizing data we may have on our various input variables, and then we move it back to a practical solution for implementation. We'll go through this cycle throughout the remainder of the course, and you'll actually see how you can utilize data in this manner to make improvements. Well, I'll stop there for this lecture. This has been a brief introduction to the term Six Sigma and a brief introduction to the DMAIC method. Also briefly pointed out the definition of perfection and what that actually means in terms of Six Sigma methodology. And then finally, we looked at transforming a problem from a practical problem to a statistical problem. And we'll spend more time doing that as we move through the course.